Okay, question 13 is a binomial expansions question. We need to expand for the first 3 terms of these 2 things here. I'm going to do one at a time. I'm going to expand 6 lots of 2 plus 3x to the minus 1 first. In order to do that, I need this to be a 1 here. So ignoring the 6 for now, I'll deal with that in a minute. I'm going to take out a factor of 2 out of here. Remembering there's still that bracket to the minus 1. So that's going to be 1 plus 3x over 2. The 2 I can bring out of that extra bracket by writing it as 2 to the minus 1. 1 plus 3x over 2 to the minus 1. So that's a half. Remember I also had a 6. So that's going to be 6 and a 6 here. So I can now write that as, remember we've said that that's 2 to the minus 1 is a half, so 6 over 2 is 3. So we've got this being equivalent to 3 lots of 1 plus 3x over 2 to the minus 1. We're going to use the binomial expansion for that, which is going to be, for the first 3 terms, it's going to be 1. Remember it's 1 plus nx. N is the power and x is whatever we've got here. So n is minus 1 and we've got 3x over 2. And the next term, the third term, is going to be n times n minus 1 times x squared divided by 2. We can simplify the terms in there. That's obviously a 1 minus 3x over 2. This is going to end up being positive. We've got 2 values that are negative here being multiplied together, so the next term is going to be positive. This 2 is then going to cancel with that 2. So we've dealt with everything here. We've then got to square the 3 and square this 2. So that's going to be 9 and square the x, of course. 9x squared over 4. And if we bring that 3 in, that's going to be 3 minus 9x squared over 2 plus 27x squared over 4. So that first one's been dealt with. We're going to do exactly the same thing for the second term. So for 4 times by 3 minus 5x to the minus 1. I'm going to take this 3 out. So that's going to be 4 over 3 times by 1 minus 5x over 3 to the minus 1. So that's now ready to expand as well. 1 again, plus nx, n's minus 1, x is minus 5x over 3. And then we're going to have minus n, which is minus 1, times minus 2, times x squared, all divided by 2. So tidying that up again, that's going to be 1 plus this time 5x over 3. And this time we're going to still have a positive because we've got 2 negatives cancelling. We've got another negative in here, but that's going to be squared, so that's positive. The 2's are also going to cancel again. So it's going to be 25x squared over 9. And if we multiply by 4 over 3, that's going to be 4 over 3 plus 20 over 9, 20x over 9 plus 100x squared over 27. So we've now got to subtract this thing that we found from the top expression, because it was the first one, take away the second one. So best thing to do for this is line them up, put them one above the other. 3 minus 9x over 2 plus 27x squared over 4. Easiest thing to deal with these is to take away each one. Don't just put a take away here, but put minus 4 over 3 minus 20x over 9 and minus 100x squared over 27. I'm going to use my calculator to work these out. So 3 minus 4 over 3 is 5 over 3. Minus 9 over 2, take away 20 over 9 is minus 121x over 18, and 27 over 4 minus 100 over 27 is 329 over 108, positive 329 x squared over 108. Okay, B wants us to find the exact value of f of 0.01. That means putting it into here rather than the approximation that we found in part 1. So f of 0.01, and it's a 2-mark answer, so it's worth telling them that you're putting the answer in here. So that's going to be 6 over 2 plus 0.03 minus 4 over 3 minus 0.05. So I'm going to work that out on the calculator and round that to 7 decimal places. So that's coming out at 1.5997328. 1, 2, 3, 4, 5, 6, 7. So that's my answer to 7 decimal places for part B. Part C then says find the percentage error made in using the series expansion in part A. So using the approximation of this rather than the number itself. So we're going to work out f of 0.01 when we're putting it in here. So 5 over 3 minus 121 over 8 times 0.01 plus 329 over 108 times 0.01 squared. Okay, so we're going to work that value out. So we're getting 1.599749. 1, 2, 3, 4, 5, 6, 7. Okay, so the percentage error is the difference over what it should be. So that's the difference between the two numbers divided by the correct value. So 1.599749 minus 1.5997328 over 1.5997328 times 100%. It's given me a percentage error to two significant figures of 0.0010.